and then interdisciplinary and both multidisciplinary, ability to synthesize the information, unconventional, and it is original thinking
Introduction
is
to
enhanced,
probability.
interdisciplinary, multidisciplinary
Probability is a
thinking
fundamental
helps students to
concept in
develop new
mathematics
awareness
and
on the
statistics
connections
that
between
helps us
the disciplines.
understand and quantify the
That's all.
likelihood
Thank
of
you.
events occurring. It provides a framework for analyzing uncertain situations and making informed decisions. This introduction will explore the basic definitions, terminology, and axioms that form the foundation of probability theory. Definitions and terminology. Sample space. The sample space denoted as lambda is the set of all possible outcomes of an experiment or event. It represents the universe of all possible scenarios that can occur. Event. An event is a subset of the sample space representing a particular outcome or set of outcomes that we are interested in. Events are typically denoted using capital letters such as A, B, or C. Probability. Probability is a measure that quantifies the likelihood of an event occurring. It is a value between 0 and 1, where 0 represents an impossible event and 1 represents a certain event. Probability axioms. Axiom 1, the probability of any event A denoted by P of A, denoted as P of A, is a non-negative real number. P of A is greater than or equal to 0. Axiom 2, the probability of the entire sample space mu is equal to P of mu equal to 1. Axiom 3, if A and B are mutually exclusive events, then the probability of their union is the sum of their individual probabilities. P of A union B equal to P of A plus P of B. Counting principle, counting techniques. Multiplication principle. The multiplication principle states that if there are n1 possible choices for the first event and n2 possible choices for the second event and so on, then the total number of possible outcome is the product of these individual choices. Permutation. Permutations represent the number of ways to arrange a set of distinct objects in a specific order. The formula for the number of permutations of n objects is n factorial. Combinations. Combinations represent the number of ways to choose a subset of k objects from a set of n objects without regard to order. The formula for the number of combination of n objects taken k at a time is nck, n factorial divided by k factorial into n minus k factorial. Conditional probability. Definition. Conditional probability is the probability of an event A occurring given that another event B has already occurred. It is denoted by P of A given B and represents the updated probability of A based on the knowledge of B. Applications. Conditional probability is widely used in decision making, risk analysis, and various fields such as medical diagnosis, traffic analysis, and forensics, where the likelihood of an event is influenced by the occurrence of other events. Formula. The formula for conditional probability is P of A given B equal to P of A intersection B by P of B, where P of A intersection B is the probability of intersection of events A and B. Bayes theorem. Bayes theorem provides a way to calculate the conditional probability of an event A given the occurrence of another event B using the prior probabilities of A and B as well as the conditional probability of B given A. What do you understand by conditional probability? What is the where you use the conditional probability? Here is the answer. So you can think that where the conditional probability is used. Conditional probability is used in decision making, where one event has already occurred and another event is followed by another event follows. The event which follows depends upon the previous event. So conditional probability in such cases it is used. You can also refer more reference, you can see independence and dependence. Independent events. Events A and B are independent if the occurrence of one event does not affect the probability of the other event. In this case, the probability of their intersection is the product of their individual probabilities P of A intersection B equal to P of A into P of B. Dependent events. Events A and B are dependent if the occurrence of one event affects the probability of the other event. In this case, the probability of their intersection is given by the conditional probability P of A intersection B equal to P of A given B into P of B. Mutually exclusive events. Events A and B are mutually exclusive if they connect if they cannot occur simultaneously. In this case, the probability of their union is the sum of their individual probabilities P of A union B equal to P of A plus P of B. Bayes theorem, prior 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 probabilities. What is prior probabilities? Bayes theorem starts with the prior probabilities of events A and B denoted by P of A and P of B. Conditional probabilities, it then uses the conditional probabilities P of B given A and P of A given B, which represent the likelihood of B given A and likelihood of A given B, respectively. Posterior probability Bayes theorem allows us to calculate the posterior probability P of A given B, which is the updated probability of A given the new information about B. Application of probability. Medical diagnosis. Probability plays a crucial role in medical diagnosis where clinicians use Bayes' theorem to assess the likelihood of a patient having a particular disease based on symptoms and test results. Financial risk management. In the beginning of the PPT, we have learned that where the probability is used. Here exactly we are discussing, this is the place that where probability is used. Probability models are used in finance to quantify and manage risks such as the likelihood of default, market fluctuations, and portfolio optimization. Weather forecasting. Probability is essential in weather forecasting where meteorologists use statistical models and historical data to predict the likelihood of various weather conditions such as rainfall, temperature, and storms. Gambling and game theory. Probability is fundamental to understanding the odds and expected outcomes in various games of chance, from casino games to sport betting, and is used in game theory to analyze strategic decision making.